All right, we are moving on here to section 9.2, writing exponential functions. We're going to identify graphs as exponential growth or decay, actually equations, not graphs, and writing equations of exponential growth functions given 2 points. So remember that exponential equations are given in the form of y equals a and then times b to the x power. The parent function would just be y equals b to the x. If it's growth, your b value here, whatever's being raised to the exponent, if that's greater than 1, sorry, that should not be there. It is growth. If it is between 0 and 1, then it is decay. So identify the following as either exponential growth or decay. So you're literally just looking at this number. If it's less than 1, it would be decay. So we have decay. If it's greater than 1, we have growth. Less than 1, so we have decay. And the last one, a little bit tricky here, because we have a negative exponent. You should technically fix that, which means we would be looking at that as our equation. And then again, instead of 2 over 1, you could just write this as 2. So that would make it growth. All right, so writing exponential functions. We need to write an exponential function whose graph passes through 1, 4, and 2, 12. So what we're going to have to do here is take our points. Let's start with the first one here. This would be x and y. We're going to take our equation. We're going to take 4, put it in for y, and then we are going to take 1 and put it in the equation for x. And then what we're going to do is we're going to solve for a. So we have 4 equals a times b to the first. Well, b to the first is just b, so I don't need that necessarily. I'll keep the parenthesis there. I guess it doesn't matter. And then if I solve for b, what I'm going to do, it means we're isolating a. What I'm going to do is divide both sides by b, so those b's cancel. So then I have 4 over b equals a. All right. Then what I'm going to do is take the other point. Okay, that's the key. You got to take the other point. So this is now x and y. So we have 12 equals a times b to the second power. And what we're going to do is we're going to replace our a that we just found with that a right there. So 12 is going to equal 4 over b. That's what we found a to be right here. Times b squared. And what that does is it gives us an equation with just one variable. Instead of a or b, we just have b. So if we clean this up a little bit, 4 over b times b squared, what I can do is I can take away one of these b's, because this is technically b over 1. And then you can cross-reduce fractions, so reduce that one down to 1. That'll get rid of that. So 12 equals 4b. Divide both sides by 4. b equals 3. Okay, now here's the tricky part. We also have to find a. So because our final equation should be y equals, and we have a number for a, we have a number for b to the x power. It should be our final equation. So we need to find a and b. Probably should have started by explaining that. The nice thing is we already have an equation solved for a right here. So we're going to take our b value that we just found, plug it in right there. So a equals 4 over 3. Simplify if you can. We can't. Now we have a, we have b, so y equals 4 over 3. And then we have 3 to the x power. And that would be our final equation. This would be exponential growth because b is greater than 1. And there you go. So let's try another example, because this is kind of difficult, but this is the last example. So again, you're going to take your first point. We'll just call this x and y. So 9 equals a b to the second. And you're going to solve this equation for a every time. So in this case, we can just divide both sides by b squared, because that's going to cancel out that. So a equals 9 over b squared, and then you stop there. Then you take your other 2 points, x and y. This is kind of a weird thing here, but I'm assuming we're going to take the square root and it's going to work out nicely. Equals a b to the 4th power, because that's x. And now what you're going to do is you're going to make another substitution. So you're going to take what we found a here, 9 over b squared, replace it for a in this second equation that we wrote. So 20.25 equals 9 over b squared times b to the 4th. So we substituted once to find a, substituted twice to write this second equation here, and then made a third substitution for a. And now we have an equation finally with just b values. So we can reduce here. This should always happen. So we can take away 2 b's, and that's going to cancel out these two. So 20.25 equals 9b squared. If we divide both sides by 9, 20.25, or no, whoops, I should probably divide actually. Let's open up the calculator here quick. 20.25, what in the world? 20, why won't it let me hit 0? There we go. 20.25 divided by 9 is 2.25. So 2.25 equals b squared, and then to solve for b, you have to take the square root. So it should be 1.5, but we'll just confirm here. So we'll go square root of 2.25 equals 1.5. Okay, so again, our final equation should be y equals, and we need a and we need b to the x power. Well, we just found b, 1.5, so it's exponential growth again. And then to find a, just take that and substitute backwards. So many substitutions here. Substitute back into here. So a equals 9 over 1.5 squared. We actually just took the square root of it. It's 2.5, so 9 divided by, or 2.25. 9 divided by 2.25. And if you just want to confirm that, 1.5 squared is that. And if we take 9 divided by 2.25, we get 4. So there's a, there's b. Again, it's exponential growth because b is greater than 1, and that would be your final answer.